Good day. Our group is assigned to discuss the mechanical properties, applications, and processing of metals. After the completion of the chapter, students will be able to list and explain mechanical properties of metals, describe dislocation and plastic deformation in materials, explain and compare fracture, fatigue, and creep, list and explain the types of metal alloys, and outline the fabrication of metal alloys. For the introduction, the mechanical behavior of a material reflects the relationship between its response or deformation to an applied load or force. Key mechanical design properties are stiffness, strength, hardness, ductility or toughness. Factors to be considered includes the nature of the applied load, which are tensile, compressive or shear, and its duration, as well as the environmental conditions. The mechanical properties are concerned to a variety of parties. Structural engineers determine stresses and stress conditions within the member that are subjected to well-defined loads. Material and metallurgical engineers concerned with producing and fabricating materials to meet services requirements as predicted by stress analysis, which are madidiscuss naman sa further lesson. Now, here are the important mechanical properties. Elasticity. It regains its original shape when the external force on it is removed. Isang example dito ay yung spring. If either tension or compressive force ay in-apply mo sa kanya, babalik siya sa original shape niya. Sa plasticity naman, it retains its deformity when the external force on it is removed. Dito naman, magkakaroon ng permanent deformity or change in dimension pag nasobrahan yung pag-apply ng force. Sa ductility naman, it is the ability to undergo significant plastic deformation before rupture or breaking. Katulad ng picture na nasa baba, pag in-applyan mo siya ng tension force, ang tendency, mag-stretch siya, tapos magkakaroon ng deformity bago siya mag-break or mag-rupture. Sa toughness naman, it is the ability to resist fracture. Self-explanatory naman siya. Malleability, it is the ability to be pressed or rolled into thin sheets without breaking. Isang example dito ay yung aluminum cans. Kapag minartilyo mo siya, hindi siya magbe-break or kahit ano man. Ang mangyayari lang ay mag-change siya into different shape or mayuyupi siya. Sa stiffness naman, measures how much stress can be applied to an element before it deforms permanently or fractures. Meaning, ito yung object na nag-resist sa deformation in response to the applied force. The more flexible an object is, the less stiff it is. Strength. Resists external force without breaking or yielding. Sa strength, meron tayong 4. Sa tensile strength, it is the ability to resist force attempting to pull it apart. Meaning, ito yung metals na merong ability na mag-resist ng opposite forces kapag in-apply. Compressive strength, it is the ability to withstand being crushed. Meaning naman, same direction yung pag-apply ng force. Shear strength, it is the ability to tolerate force trying to slice it or cut it. Meaning, may resistance siya or malaki yung resistance niya kapag ini-slide yung force na ina-apply sa object na yon. Sa torsional strength, it is the ability to resist force attempting to twist it. Sa kanya naman, pa-twist. Grip, ability to withstand sustained loading without significant continuous deformation, significant factor at significantly elevated temperatures, meaning it is the tendency to slowly deform permanently under the influence of persistent mechanical stress, meaning dependent siya sa time, tsaka kinoconsider din yung temperature. Sa resilience naman, it is the ability to absorb energy and still return to its original state. Next, the concepts of stress and strain. When a metal is subjected to a load or force, it is distorted or deformed no matter how strong the metal or light the load. If the load is small, the distortion will probably disappear when the load is removed. The intensity or degree of distortion is known as strain. Dito, if the deforming force is applied, interatomic or intermolecular forces will be closer as they are before. Kapag naman in-release yung deforming force na yun, it brings back the object to its initial state. Sa strain naman, it simply means change in dimension. The displacement or size of deformation is directly proportional to the deforming force or load. It simply means kapag nag-increase yung deforming force, mag-increase din yung size of deformation. In stress-strain curve, strain or the deformation is independent and comes as a result or the externally applied force, so it is taken in x-axis, where stress comes in order to resist the deformation in terms of resisting force, so it is dependent on strain and comes in y-axis. External force to deformation to strain to resisting force to stress. Hence, strain comes first and independent and in x-axis, whereas stress comes later and dependent on strain in y-axis. Meaning, kapag nagkaroon tayo ng external force, magkakaroon ng deformation. And yung deformation na yun, it means strain. Sa strain na yun, magkakaroon tayo ng resisting force at magpuproduce yun ng stress sa object na yun. Engineering stress is the applied load divided by the original cross-sectional area of a material, also known as nominal stress. Ito yung formula. Sigma is equal to force over cross-sectional area. These are the types of stress. Tensile stress. Type of stress in which two sections of material on either side of a stress plane tend to pull apart or elongate. Meaning, sa isang material, magkakaroon tayo ng opposite side or opposite direction ng forces. So, compressive stress, the reverse of tensile stress. Adjacent parts of the material tend to press against each other through a typical stress plane. Meaning, sa isang material, magkakaroon tayo ng same direction ng forces. Sa shear stress, exists when two parts of material tend to slide across each other on any typical plane of shear upon application of force parallel to that plane. Dito naman, nagkakaroon tayo ng sliding forces sa material na yon. Strain. Engineering strain is the amount that a material deforms per unit length in a tensile test, also known as nominal strain. Ang formula naman ay strain is equal to total elongation or change in length over the original length. Types of strain. Elastic deformation. Transitory dimensional change that exists only while the initiating stress is applied and disappears immediately upon removal of the stress. All the atoms are displaced the same amount and still maintain their relative geometry when the stresses are removed. All the atoms return their original position and no permanent deformation occurs. Katulad ng sa elasticity kanina, bumabalik lang siya sa original state or original shape niya. Sa plastic deformation naman, dimensional change that does not disappear when the initiating stress is removed. Katulad ng sa plasticity kanina, magkakaroon ng permanent deformity kapag nag-apply tayo ng more force dun sa object na yun.
Forming operations, mechanical properties, applications, and processing of metals. Forming operation is a fabrication process in which the shape of a metal piece is changed by plastic deformation. It's a set of manufacturing processes in which the material is deformed plastically to take the shape of the die geometry. The tools used for such deformations are called die, punch, and etc. And it depends on the type of the process. Plastic deformation is stresses beyond yield strength of the workpiece material is required. Process of deformation. Hot working. When deformation is achieved at a temperature above that at which recrystallization occurs. Hot working involves deformation above recrystallization temperature. The advantage of hot working is significant plastic deformation can be given to the sample, significant change in the workpiece shape, lower forces are required, materials with premature failure can be hot formed, and absence of strengthening due to work hardening. The disadvantage of hot working are shorter the tool life, poor surface finish, lower dimensional accuracy, sample surface oxidation. Next is cold working. produces an increase in strength with the attendant decrease in ductility because the metal strain hardens. Advantage over hot working includes a higher quality surface finish, better mechanical properties, and a greater variety of them and closer dimensional control of the finished piece. Cold working is generally done at room temperature or slightly above room temperature. The advantages of cold working are closer tolerance can be achieved, good surface finish, higher strength and hardness is seen in part because of strain hardening. Grain flow during deformation provides the opportunity for desirable directional properties. Since no heating of the work is involved, furnace, fuel, electricity costs are minimized, and machining requirements are minimum, resulting in possibility of near-net shape forming. The disadvantages of cold working are higher forces and power are required. Strain hardening of the work metal limit the amount of forming that can be done, and the workpiece is not ductile enough to be called work. Operations. The different operations in forming operations of metal are divided into four. First is forging, mechanically working or deforming a single piece of abnormally hot metal. This may be accomplished by the application of successive blows or by continuous squeezing. The workpiece is compressed between two dies containing shape contours. It is used to make a variety of high-strength components for automotive, aerospace, and other applications. The components include engine crankshafts, connecting rods, gears, aircrafts, structural components, jet engine turbine parts, and etc. Next is rolling. The most widely used deformation process consists of passing a piece of metal between two rolls. A reduction in thickness results from compressive stresses exerted by the rolls. In this process, the workpiece in the form of slab or plate is compressed between two rotating rolls in the thickness direction, so that the thickness is reduced. The rotating rolls draw the slab into the gap and compresses it. The final product is in the form of sheet. Extrusion. A bar of metal is forced through a die orifice by a compressive force that is applied to a ram. The extruded piece that emerges has the desired shape and a reduced cross-sectional area. In this operation, the workpiece is compressed or pushed into the die opening to take the shape of the die hole as its cross-section. And last is drawing. Pulling of a metal piece through a die having a tapered bore by means of a tensile force that is applied on the exit side. Wire or rod drawing, similar to extrusion, except that the workpiece or material is pulled through the die opening to take the cross section. This is the example of the forming operations. Casting. Casting, fabrication process whereby a totally molten metal is poured into a mold cavity having the desired shape. Upon solidification, the metal assumes the shape of the mold but experiences some shrinkage. Casting methods are typically used to create intricate solid and hollow shapes, and cast products are found in a wide range of applications, including automotive components, aerospace parts, and etc. Sand casting. Two-piece mold is formed by packing sand around a pattern that has the shape of the intended casting. Most common method, ordinary sand, is used as the mold material. Sand casting generally consists of finely ground spherical grains that can be tightly packed together into a smooth molding surface. The casting is designed to reduce the potential for tearing, cracking, or other flaws by allowing a moderate degree of flexibility and shrinkage during the cooling phase of the process. The sand can also be strengthened with the addition of clay, which helps the particle bonds more closely. Automotive products such as engine blocks are manufactured through sand casting. Sand casting involves several steps, including pattern making, molding, melting, and pouring and cleaning. Next is die casting. Liquid metal is forced into a mold under pressure and at a relatively high velocity and allowed to solidify with the pressure maintained. Die casting is a method of molding materials under high pressure and usually involves non-ferrous materials and alloys such as zinc, tin, copper, and aluminum. The reusable mold is coated with a lubricant to help regulate the die's temperature and to assist with component ejection. Molten metal is then injected into the die under high pressure, which remains continuous until the workpiece solidifies. This pressurized insertion is rapid, preventing any segment of the material from hardening before being cast. After the process is completed, the component is taken out of the die and any scrap material is removed. Next is investment casting. The pattern is made from a wax or plastic that has a low melting temperature. Around the pattern is poured a fluid slurry which sets up to form a solid mold or investment. Plaster of Paris is usually used. Investment or lost wax casting uses a disposable wax pattern for each cast part. The wax is injected directly into a mold, removed, then coated with refractory material and a binding agent. Usually in several stages to build up a thick shell, multiple patterns are assembled onto common sprues. Once the shell have hardened, the patterns are inverted and heated in ovens to remove the wax. Molten metal is then poured into the remaining shells where it hardens into the shape of the wax patterns. The refractory shell is broken away to reveal the completed casting. Investment casting is often used to manufacture parts for the automotive, power generation, and aerospace industries such as turbine blades. Next is lost foam casting. The expandable pattern is a foam that can be formed by compressing polystyrene beads into the desired shape and then bonding them together by heating. Lost foam casting is a casting method used to create solid metal parts from molten metal. Lost foam casting is a process used to create complex metal pieces and parts in which molten metal evaporates a foam mold being held still with sand. The process starts with a polystyrene foam as the mold material, which can be carved, machined from a foam block, or created using a process similar to injection molding. The latter process uses beads of polystyrene that are heated inside an aluminum die to expand and fill the die. A completed polystyrene foam mold is then covered with a ceramic refractory coating to create a barrier between the foam and the sand in which the foam mold sits. The small amount of waste gas created can escape into the sand. Last is continuous casting. The refined and molten metal is cast directly into a continuous strand that may have either a rectangular or circular cross-section. Solidification occurs in a water-cooled die having the desired cross-sectional geometry. Continuous casting is highly automated and more efficient. Continuous casting, also known as strand casting, is the process where a metal is heated until it liquefies. The molten metal is then allowed to solidify until it becomes a semi-finished lump that is later rolled in the finishing mill. It is used to cast metals of uninterrupted lengths. In this process, the molten metal is continuously supplied to the mold. The mold has an intermediate length When the molten metal is cast through a mold, it keeps traveling downward, increasing in its length as the time passes by. The molten metal is continuously passed through the mold at the same rate to match the solidifying casting. This results in casting of long strand of metal. The whole process of continuous casting is precisely deliberated process that can be produce outstanding results. Miscellaneous. Powder metallurgy involves the compaction of powdered metal followed by a heat treatment to produce a more dense piece. Powder metallurgy is a metal forming process performed by heating compacted metal powders to just below their melting points. Involves mixing elemental or alloy powders, compacting the mixture in a die, and then sintering or heating the resultant shape in an atmosphere-controlled furnace to metallurgically bond the particles. Powder metallurgy is a long-standing method of producing nickel-based alloy components used in turbine engines. The advantage of the powder metallurgy technique is that high-quality, near-net shape, and homogeneous parts can be made with substantially reduced machining and scrap. Welding. Two or more metal parts are joined to form a single piece when one part fabrication is expensive or inconvenient. Welding is a fabrication process whereby two or more parts are fused together by means of heat. Welding processes are commonly used across a range of industries including aerospace, automotive, energy, and constructions. Used to join metals, thermoplastics, or wood for a variety of applications. And that's our report. Thank you for listening and God bless.